Hey everyone! So, we're going to talk about one of the most important pieces of code out there today. It's a Python library that, kind of quietly powers everything, from hardcore scientific research all the way to the latest in artificial intelligence. Yep, we're talking about NumPy. All right, let's just jump right in with a question. Have you ever been, deep in some Python code, and you've got this massive list of numbers to crunch? We're talking thousands, maybe even millions, and everything just slows down to a crawl. It's super frustrating, right? So why does that happen? Well, the whole reason for that slowdown comes down to the difference between Python's regular old lists and NumPy's special arrays. Think of a Python list like a Swiss Army knife. It's awesome, right? Super flexible. It can hold anything you throw at it. Numbers, text, even other lists inside of lists. But a NumPy array, that's more like a high-performance socket wrench. It's built for one specific job, and that's doing math with numbers, and doing it incredibly, incredibly fast. Okay, so to really get a feel for this problem, let's walk through a super simple example. Imagine you have a giant list of numbers, and all you want to do is double every single one of them. Now, if you're using a standard Python list, you have to spell out every single step for the computer. It's like, okay, step 1, create a new empty list. Step 2, grab the very first number from my original list. Step 3, multiply that by 2. Step 4, stick the result in my new list. And then you do it all over again for the next number, and the next. If you've got a million numbers, that's literally a million separate little operations. You can see how that gets really inefficient really fast. So how do we get around this? Well, this is where the hero of our story comes in, the NumPy array. And trust me, it's a completely different way of thinking about your data. It absolutely changes the game. Okay, so what is a NumPy array? It's basically a grid of values, but it has two really, really important rules. First rule, everything in the array has to be the same type of data. All numbers have to be integers or they all have to be floats. No mixing and matching. Second rule, and this is the big one. All those values are stored right next to each other in one continuous block in your computer's memory. The best way to think about it is, imagine your tools are scattered all over your garage. That's a Python list. Finding what you need takes time. A NumPy array is like having all your tools perfectly organized in one single toolbox drawer. You can grab exactly what you need instantly. That structure is the secret sauce to its speed. And now look at this. This one line of code, this replaces that entire 5-step loop we just walked through. Seriously, you don't have to tell NumPy to go number by number. You just say, hey, take this whole array and multiply the entire thing by 2. That's it. One command. It's clean, it's simple, and it is just ridiculously fast. So what is the magic behind this? How can one line be so much more powerful? Well, it all comes down to a really important concept in high-performance computing. It's called vectorization. And this right here is the key mental shift you have to make. Instead of thinking about your data as a long list of individual things that you have to process one by one, NumPy lets you think about the whole thing as a single entity. You apply an operation to the entire vector, the whole array, all at once. And check out the payoff. This chart just lays it all out. If we look at the time it takes to do the exact same job, the difference is just staggering. Let's say the Python loop takes 100 seconds. The vectorized NumPy operation, it takes 5. This isn't just a little bit better, it's a monumental leap forward. This is the kind of speed that actually makes modern large-scale data science even possible. But wait, there's more. NumPy isn't just about raw speed. It's also about incredible flexibility. Let's check out another one of its superpowers, the ability to reshape data in an instant. Okay, so let's say you start with this. Just a simple, flat, one-dimensional line of 12 numbers. Nothing fancy, just a list of data. Now, if you wanted to turn that into, say, a grid or a table using plain Python, you'd be writing some pretty gnarly nested loops. It's a pain, but with NumPy, it's a single command. Boom. You can instantly reshape that same data into a 2-dimensional grid, a matrix with 3 rows and 4 columns. And the cool part is, you haven't actually changed the underlying data at all. You've just changed its shape. You're just looking at it differently. And it gets even crazier with a feature called broadcasting. This is a super clever trick that lets NumPy do math on arrays that aren't even the same shape. So say you've got a big grid of sales figures. With broadcasting, you can add a single number, like a $10 bonus, to every single sale in that grid, all in one go. NumPy is smart enough to stretch or broadcast that single number across the whole grid for you. It's incredibly powerful. Okay, so let's tie all this together. We've got speed, we've got vectorization, we've got this amazing flexibility. But so what? Why does any of this actually matter in the real world, outside of just being a neat coding trick? Well, it matters because NumPy isn't just another library. It's the bedrock. It's the foundation that pretty much the entire modern data science and AI world is built on. You've heard of pandas for data analytics? Or how about the big AI frameworks like TensorFlow and PyTorch? Scientific computing, complex modeling, even the libraries that make pretty graphs, they all depend on NumPy under the hood to do the heavy lifting with the numbers.
So when you look at how data scientists actually work, you can see how all these pieces fit perfectly together. Yeah, the super fast core operations are the biggest piece of the pie for sure. But being able to reshape data on the fly, generate random numbers for simulations, or instantly calculate things like the mean or standard deviation, all those things together are what make NumPy such an absolutely essential tool.
And that's a wrap on our dive into NumPy. It truly changed the game by getting us to stop thinking about numbers one by one and instead start thinking about data in whole chunks, in arrays. So I want to leave you with this final thought. If that shift in perspective was the last big revolution, what's the next huge idea that's going to completely change how we look at data all over again?